All right, so today we are going to be adding and subtracting polynomials. When you were in Algebra 1, you learned to add and subtract up to quadratics, right? In Algebra 1, you added and subtracted quadratics and linear functions, okay? But now we're going to do it for any kind of polynomial. So, a polynomial in standard form goes from greatest degree to lowest degree. All right, so there we go. So a polynomial in standard form goes from largest degree, biggest degree, to smallest, biggest, degree to smallest. Okay, so this is a form of a polynomial function. It's a function because it's equal to some p of x. The part that's just an expression we call the polynomial. Notice that each of my x terms has a coefficient. We represent those coefficients as a sub n, but those will end up being numbers. So each term on its own is a monomial. Each term on its own, each individual term in there is called a monomial. So the an x to the n, that's a monomial. An minus 1 x to the n minus 1, that's a monomial. Something without addition or subtraction is a monomial, mono, one. But when you put a bunch of monomials together, you get a polynomial, so many. All right, the degree of a monomial is the sum of the exponents of its variables. The degree of a polynomial is the degree of the monomial with the greatest. All right, so if there's 10 different terms, you find which of those terms on its own has the biggest degree, and you call it based upon that. All right, so on A, let's look at this list. All right, Jacqueline, can you give me an example of one of these that's a monomial? 3y squared would be a monomial on its own. Right now they're separating these things by commas. So 3y squared has y in front of it and the minus 5y cubed. So even though on its own, that actually is correct that 3y squared would be a monomial. Once it's connected to those other two though, it's no longer, or other three, it's no longer a monomial. So in its full form between the commas, could you give me an example of one that's a monomial?
76.
Yep, 76 is a monomial. All right, Axel, can you give me an example of a monomial? So is there one of those in between the commas that has no addition or subtraction?
The variable?
Which one?
The a?
The a squared b c to the 12?
Yeah.
That is an example of a monomial. Very good. So this one's a monomial because it has multiplication. That's okay, but it doesn't have addition or subtraction. So that is an example of a monomial because there's no addition or subtraction. All right. Jessica, can you give me an example of another monomial? X cubed is a monomial because it's a variable without any addition or subtraction. All right, so that leaves me with y plus 3y squared minus 5y cubed plus 10 as being not a monomial. This one is not a monomial. Why, Jose? Why is this not a monomial? Because that's addition and subtraction. Very good. Very good. All right. So if we're looking at x cubed, what's the degree of x cubed? Third, because its greatest exponent is 3. What's the degree of a squared bc to the 12th? Does b have an exponent? Trick question. Guys, if you don't see an exponent, it's to the first power. So that b is to the first power because how many b's are there? There's one of them. So a variable without an exponent is to the first power. So this is really 2 plus 1 plus 12. So it's 15. Sorry, that's 15. 15.
If you see 1 that doesn't have an exponent there, is that to the 0 power or is it to the first power?
It's to 0 power. Constants are to the 0 power. Because the only way to make a variable disappear is by putting it to the 0 power. So constants on their own, constants are to a 0 power. So 76 is a 0 power. Constants have a degree of 0 because it's all about the variable, the exponents of the variables. And since there are 0 variables there, the only way to make like x disappear is x to the 0 power. All constants have a degree of 0. All constants, all of our real numbers have a degree of 0. So in those columns, I have 3, 15, and 0. All right, so in y plus 3y squared minus 5y cubed plus 10, it's saying identify the terms. Well, your terms are the parts separated by addition and subtraction. So, here we go. So y on its own is a term. 3y squared on its own is a term. So y, that's a horrible y. Y is a term. 3y squared is a term. Negative 5y cubed is a term. 10 is a term. So how many terms are there?
4.
4. Terms are separated by addition and subtraction. So let's see. Let's figure out the coefficient of each of them. Coefficient is a number in front of the variable. So on y, what's its coefficient? 1. Good. On 3y squared, what's its coefficient?
3.
On negative 5y cubed, what's its coefficient? On 10, what's its coefficient? 10. 10. It would be a degree of 0, but it has a coefficient of 10. So now let's identify the degrees. What's the degree of y?
1.
What's the degree of 3y squared?
2.
What's the degree of negative 5y cubed?
3.
What's the degree of 10? All right. So, if we want to write it in standard form, does anybody remember what standard form is? So in general, it's writing it from the greatest degree to the smallest degree. So what's our greatest degree here? So we'll start with negative 5y cubed. Then it will be followed by 3y squared. 3y squared is positive, so I put plus. Then I'll follow by y, and I'll end by having 10. So now it's in standard form from greatest degree to least. What is the leading coefficient of this polynomial? Good. Your leading coefficient is always the coefficient of the term with the greatest degree. All right. So does some of that look a little familiar from Algebra 1? Identifying some pieces? Yes. All right. All right. So how do we add polynomials? How do we add polynomials? There are a couple strategies you could use. I'm going to caution you on the first one. I'm going to caution you on the first method they're showing you. This is called, okay, this is a vertical way of adding terms. The reason I caution on this form is because if you're missing a term, you have to leave spaces. And so that can be, you've got to be careful of that. So I'm going to go ahead and work out example B with you guys though. So on B, I have two polynomials here. So the first thing we encourage you to do is to write it in standard form. All right, so we rewrite them in standard form from greatest degree to least, from greatest to least. And now we want to group like terms. So the second thing we want to do is group like terms. All right, so what makes things alike? Well, things are like terms if they have the same variable to the same degree. So 6x to the fourth has the same variable in the same degree as negative 7x to the fourth. So I'm going to pair those together. Negative 18x cubed would match with 2x cubed. Yes, thank you. That is negative. We got to keep the sign with it. All right. 10x would go with x. And then my constants go together. So negative 2 and 5 pair together. Now guys, sometimes they won't have a pair. And if they don't have anything that matches, then it will be left alone with the final answer. It'll be like it originally was. So what I'm going to do is add. When it says add, you're going to add the coefficients. You're adding the coefficients. When you add and subtract polynomials, none of your degrees change. When you add and subtract polynomials, your degree does not change. Your exponent does not change. Your exponent does not change. So if I have 6x to the fourth minus 7x to the fourth, how many x to the fourths do I have? Negative 1. Negative 1 x to the fourth. Could I write that as just negative x to the fourth?
Yes.
Yes. All right, negative 18 plus 2x cubed. Well, negative 18 plus 2 is negative 16. All right, 10x plus x is 11x. Negative 2 plus 5 is 3. And there's your answer. So you just combine the like terms. You're combining the like terms. The amount of work you show on these types of problems really is going to vary depending on what you need to see to understand the structure. All right, so just know I'm going to show you, again, the maximum amount of work. And it's okay if some of these steps you're able to do in your head. It's okay if some of it you do in your head. Now, guys, even though other orders of this polynomial are still correct polynomials, they would not be the standard form. I'm going to ask you guys, please always put your answer in standard form. And to be honest, the number one reason we put it in standard form is it's going to be easier for us to compare our answers. If we all write our answers in standard form, it's just an easier way to compare our work. Okay, so please write your final answers in standard form, biggest exponent to smallest. All right, so let's take a look at the your turns. Why is it doing that? Okay, so we're going to take a look at the your turns. All right, so I'll do number 3 with you and then have you guys try number 4. So, here's how I like to do. Here's how I tend to go about it. Rather than rewriting in standard form, I just start looking to group them from greatest to least. So I go through and look for my biggest exponent. What's my biggest exponent? All right, are there any other exponents to the 7th power? So this one's going to hang out by itself because there's nobody else for it to combine with. Then what's the next biggest exponent after 7? All right, are there any other 4s for it to combine with? So that one's going to be left alone. Okay, what's my next biggest exponent? Okay, are there any others of them? So these two are going to combine. So negative 2x cubed and 11x cubed are going to combine together. We're combining the two polynomials. We're adding them. Yeah, so the next step we'll write that. If you want to just write that in right now, that's fine though. All right, what's my next biggest exponent? Is there any other 2s? Okay, so I'm going to combine those. So I'm going to have 8x squared minus 8x squared. All right, what's my next biggest exponent? So it'd be the 4, good. So, and that would go with the 12. All right. So do the negative 9x to the 7th and the 17x to the 4th combine? No, because they have different degrees. So those we just leave alone. So those again come down exactly as they were. But the negative 2x cubed and the 11x cubed become 8x squared minus 8x squared becomes nothing. Good. It's 0x squared. So they're canceling each other out basically. 4 plus 12 becomes, there we go. All right, you guys try number 4, please. You guys try number 4. You want to go do number 4 on the board? Yeah.
Oh yeah. 15 years? That's like 20 years and 20 years.
Okay, guys, raise your hand if you're doing some PSAT on Wednesday. Wait, what? PSAT on Wednesday? Okay, so someone on Wednesday.
Oh, yeah.
All right. So there goes multiplying polynomials on Wednesday. Are you guys back in class by today?
I think we'll get back in class at the end. Like beginning of 6th.
We have to do it Thursday. It just has to do division into one and one. And division's really the concept. Maybe I'll see if this is going to be a guest teacher or something. All right, so check our work. We should have 3x to the 11th plus x to the 6th plus 4x to the 4th minus 9x plus 17. Beautiful work. So notice, most of the work she did was just an organizing of the problem itself. She didn't actually write them as separate steps, and that is just fine. That is just fine. All right, now, what if we subtracted instead? What do we do if we change this to subtraction? Can somebody erase that really quick, please?
Yeah.
Thank you.
That's Cassandra working.
That's my Duchess right there. Now it hurts to stop. It's going like...
All right, thank you very much. All right, so notice this time I have a negative in the middle. You need to be very cautious when there's a negative in the middle, okay? Because that negative, that's subtraction. So that negative applies to everything in the polynomial it's touching, okay? Everything in the polynomial behind it. So this negative is going to apply to the 9. It's going to apply to the 2x squared. It's going to apply to the 10x to the 5th. So the first thing you want to do is you're going to distribute that negative to each of those terms. If you distribute that negative to each of those terms, you can rewrite this as an addition problem. If you distribute that negative to each of those terms behind it, it becomes an addition problem. So that becomes a negative 9. That becomes a negative 2x squared. And that becomes a negative 10x to the 5th. So notice that negative applies to every single one of those items. All right, and so then when they rewrite it, they rewrote them in standard form. So now it just becomes an addition problem. So the one thing to be careful of with these negatives is to remember to distribute it. Okay, that negative applies to everything. The number one mistake is people only apply the negative to the first number. But the negative applies to all the terms in the parentheses. All the terms in the parentheses. So now as I go to combine, what would negative x to the 5th combine with? What would 8x cubed combine with?
Nothing.
Okay, so 8x cubed is hanging out with itself. All right, what would negative 4x squared combine with?
Negative 2x squared.
So negative, and then what would 19 combine with? So negative 5x to the 5th minus 10x to the 5th?
Negative 15x to the 5th.
8x cubed comes down as is. Negative 4x squared minus 2x squared.
Negative 6x.
And then 19 minus 9. So guys, was the sum of two polynomials still a polynomial? When we added two polynomials, is the answer still a polynomial?
Yeah.
When we subtracted two polynomials, was the answer still a polynomial?
Yes.
So those are important concepts to understand, that It's called closed under addition and closed under subtraction. That if I start with two polynomials, the result will be another polynomial. If I subtract two polynomials, the result will still be a polynomial. Because remember when...
But what if you add the polynomials, but they're all negative terms, so they cancel out the other polynomials?
It would be a polynomial of 0, which is still, it's a monomial then, which is still a subset of the polynomials. And so yeah, no matter what you do, addition and subtraction will always create. And so that's actually called, that would be like a null polynomial because it has 0 value to it. But it's still classified under it. When we did complex numbers, remember that imaginary numbers were not necessarily closed under subtraction because you could make the imaginary part go away. It would become a real number. So imaginary numbers became real if you got rid of all the i's. Imaginary numbers were not closed under multiplication. All right, but polynomials are. Polynomials are. So let's look at the your turn again. I'll do one with you and then have you guys try one. All right, so the first thing I'm going to do, I'm going to distribute my negative. So my first polynomial I'm going to leave alone. My first polynomial I leave alone. I don't touch the first polynomial, but I'm turning this into an addition problem. To turn it into an addition problem, I distribute that negative. So my negative 9x to the 4th becomes positive 9x to the 4th. 6x squared becomes negative 31 becomes. All right. So 23x to the 7th, what would it combine with?
Nothing.
Is there an x to the 6th?
No.
Is there an x to the 5th?
No.
Is there an x to the 4th?
Yes.
All right, are there more than one x to the 4th?
Yes.
So what do they combine to be? Okay, I'll just write it like that then. Nobody's going to answer. All right, is there an x cubed?
Yeah. No.
Is there an x squared?
Yes.
Does it combine with anything?
No.
Is there an x?
Yeah. 31 and 1.
X.
Oh, regular. No.
No. Is there a constant?
Yes.
1 and 31. So this time there was two things that are going to combine, two sets that will combine. So what does negative 9x to the 4th and 9x to the 4th become?
0.
Good, they cancel. What does 1 plus 31 become?
32.
Hey, you guys try 7. You guys try 7.